Welcome to this online course on mechanical behavior of polymers and composites. This is week 1 where we will look into the introduction of polymers. In this video, we will look at a brief history of polymers and their characteristics as well as applications. This will give us an overview of what we will be looking in this course. So, let us start with polymers. As we look around, they are both natural as well as synthetic polymers. Natural polymers we get both from the animal world as well as the plant world. So, silk, wool and collagen, all of these are from the animal world. Silk will get from silkworms and wool from the sheep, and collagen is in the human tissues or animal tissues, mostly in skin or other tissues. We also find natural polymers in plants such as rubber, which we get from latex of the rubber plant, and cellulose, which we get from wood stock. So, cellulose is a very abundantly available natural polymer. So, the interesting thing is natural polymers, the polymer structure is very much close to what we see in synthetic polymers. So, what are synthetic polymers? These are man-made polymers formulated either by chemists or chemical engineers to meet a specific requirement, and mostly they are used in engineering applications as well as day-to-day life. But in this course we are focusing on engineering applications of polymers. Some of the examples include the water bottles, tires as well as prosthetics, which are all made up of polymers. Now, let us see a brief history of polymers. This will help us understand where we started with polymers and then see the way ahead how things are going in future. So, we have been using polymers for several thousand years. So, think about fabrics as well as paper we have been using for more than 1000 years. Now, let us see how the synthetic polymers evolved. So, in 1839 Charles Goodyear he vulcanized natural rubber. Natural rubber, as you know, is very soft, but when you add sulfur to it, it hardens and improves the properties. This led to several applications of vulcanized rubber because of these advantageous properties. Next, in 1869 John Hyatt invented celluloid. Celluloid is a very interesting material and it has a very interesting story. So, these are the billiard balls. In 1860s there is a huge demand for these billiard balls because people started playing billiards in those days, and these balls are made up of ivory coming from elephant tusk. So, there is a big demand for these billiard balls, but then there is a shortage because of natural resources. So, to overcome this, the manufacturer of these balls announced a price of around $10,000 to someone who is creating an artificial material as a replacement to ivory. So, John Hyatt worked on it and he invented this celluloid. He basically combined nitrocellulose with camphor to come up with this new material called celluloid. So, though initially it was a success, later because of some disadvantages of celluloid, other materials has replaced these celluloid billiard balls. But there are other applications of this celluloid such as movie films. So, as you can see here, movies are sometimes called celluloid because that is the name of the material with which the film is made. But there are other applications also, including these table tennis balls, which until recently have been made because of made with celluloid. Later in 1888 John Dunlop invented these pneumatic tires, which were initially used for bicycles and later for automotives as well. And then in 1907 bakelite is first invented. So, this is the first synthetic polymer which is completely made up of synthetic raw materials. So, even the raw materials are petroleum products, so that they are synthetic and not natural. So, one application is the old telephone casings, but this is also used to make these billiard balls by replacing celluloid. But there are several other applications of bakelite, such as in electrical switches, as well as many toys were made up of bakelite. Next, in 1938, nylon was invented. This is the first fiber made only from chemicals. So, fibers, as you know, have been used from ages. So, for example, the fabrics are all made up of fibers, and these fibers are both coming from natural as well as synthetic polymers. But nylon is the first synthetic polymer or first synthetic fiber which has been invented, and it found several applications, such as in, of course, clothing, but also in fishing nets and other applications. Next, in 1946, polyesters were invented. These are again clothing materials, but they have very good properties, like they are wrinkle free as well as they can be dried easily. So, they have been used in fabrics. They are also used in safety belts, such as shown here. Lastly, in 1947, epoxy was invented. This is a very abundantly used structural polymer in recent times. This has been used in composites, but also in adhesives which are used to glue to components. So, they are used in adhesives and composites. What I show on this slide is only a very small amount of polymers, just to give you a flavor about what are the different polymers and when these have been evolved. But there have been several thousand polymers which we use or which people have been inventing even now. So, the recent polymers are mostly a blend of two or more different polymers, or sometimes even additives are added so that they improve specific properties. So, because of these blends and additives, there have been an explosion of new polymers which are coming every day. So, having seen a few polymers, now let us look at the characteristics of these polymers and see why they are very popular and used in our daily lives and as well as in our specific specialized applications. So, we will start with the advantages of these synthetic polymers. To start with, high specific modulus and strength. So, what is specific modulus? Specific modulus is nothing but modulus by density. Polymers, as we know, are low density or light materials, but though the modulus might be low compared to other structural materials like metals, because of low density, this ratio is comparable or sometimes even better than the traditional structural materials. The same thing with strength, specific strength, which is again strength by density. So, these have superior or high specific modulus and strength, which make them a better candidate to replace or use in some structural applications. Second is the corrosion resistance. Like metals, they do not corrode, but there is another form of corrosion which we call as degradation in polymers, but usually this is a very it takes a long time for a polymer to degrade. So, that is one other advantage of polymers. They also have low heat conductivity and low electrical conductivity. So, this is the reason why we use polymers in most of the applications, such as in wires. So, electrical wires, they have a lining of these polymers because of the low electrical conductivity. But we also use polymers where we need to protect from heat conductivity as well. But the most important reason why polymers are mostly used is because it is very easy to process, meaning the manufacturing methods are such that, for example, blow molding, this can be used in mass producing components. and therefore, the price of these components are very less compared to any other methods, compared to the structural materials like metals, how they are manufactured. Compared to that, polymers are very cheap because of the low processing and manufacturing costs. But in addition to these advantages, they do have several few disadvantages. Most important of that is the environmental impact. This is because unlike natural materials, polymers do not degrade quickly. So, it takes several hundred years for the polymers to degrade and decompose in the earth. The other disadvantage is the chemical sensitivity. Though they are stable, but few polymers are reactive with few chemicals. So, when these chemicals are in contact with these polymers, then again they decompose or degrade. They also have low melting point compared to metals, where the melting points are in the order of 1000 or more, but for polymers these melting points are around 100, 200 depending on the kind of polymer we use. So, which means that depending on the kind of application we use, let us say if you are designing a component which is close to a engine where it is hot, then probably plastics are not so advisable because the temperatures might be high, but they can be used where the temperatures are moderate. And finally, the strength of the polymers are less compared to metals. So, depending on the application, and sometimes not all applications are primary structures. Primary structures means the load bearing structures. Some of them are secondary structures, meaning they are there not to bear the loads, but mostly for functionality purpose. So, plastics can be used in secondary structures where the functionality is met. So, if you for example look inside a car, you will see in the interiors most of it is plastic because they are not the load bearing materials, but the actual load bearing materials are either made up of strong metals or with composites. Having looked at both advantages and disadvantages of polymers, now let us look at their applications. We will start with fibers. Fibers, as I mentioned, fibers we get from different sources. From plants we get this cotton and rayon, and from animals we get silk and wool. But synthetic fibers are what are mostly used in the engineering application. These include the nylon 66 and Kevlar. Nylon 66, as I mentioned, we can use it for fishing lines as well as fabrics, and Kevlar is a material which is very tough. So, which means it can take lot of energy before failure, and this is the reason why it is used for bulletproof jackets. So, next there are these fiber reinforced plastics, which we call it as composites. Here fibers are used to reinforce plastics. So, what kind of fibers do we commonly use? We use glass fibers, carbon and Kevlar fibers, and the matrix material is mostly used to bind these fibers together. So, the materials used are mostly epoxy, which is a very structural polymer, and PEEK. Because of these fibers which can take high strength and modulus, as well as the matrix which binds these fibers, there are many applications including aerospace applications and automotive applications where you need high performance as well as low weight. They are also used in boats and tennis rackets, such as shown here. So, next adhesives is one big industry where polymers are used. Adhesives are used to bond structural components. So, again the commonly used polymers are these epoxy as well as cyanoacrylate. Polymers are also used for insulations, mostly to insulate the electrical wires, where polyvinyl chloride and polyethylene are used. The reason why they are used is because they are again poor electrical conductors. Polymers also can be made transparent. Because of it, they have application in optics, such as the lenses, the glasses we have are mostly made up of polymers, as well as the windows which we can see through. These are mostly made up of polymers such as acrylic and polycarbonate. So, usually this polycarbonate, in short we write it as PC, polyethylene, in short we write it as PE, and polyvinyl chloride we write it as PVC. So, you might be recognizing these by these names. So, for example, when we say PVC pipes, we mean polyvinyl chloride, and polyethylene used in water bottles or plastic bottles, as we call it. Now that we have looked into a brief history of polymers and then what are the advantages and disadvantages of polymers, we have also looked into the applications of polymers. But let us see what are the topics we will be covering in this course and how this will be useful for you to take it further as a designer or an analyst working on polymers. So, from next video onwards, we will be looking at the polymer structure. So, the reason why we are looking at polymer structure is not from a chemist point of view, but from a mechanical point of view, meaning we want to connect the structure of the polymer to its properties. So, we will connect the structural properties with the mechanical properties. So, there are very interesting mechanical properties that a polymer displays and which are very different from those properties shown by metals. So, there is a need for us to understand these mechanical properties which will help us in choosing the best suited polymer for a particular application. Then we will go into the mechanics of polymers. Polymers have a very different behavior from regular metals. They display this viscoelastic behavior, meaning visco means liquid behavior and elastic meaning solid behavior. So, they display the behavior of liquid as well as solid. So, it is neither completely liquid nor solid, but somewhere in between. So, this we call it as viscoelastic behavior, which is time dependent. So, we will be looking in depth about the viscoelastic behavior and how to model this viscoelastic behavior for stress and strain analysis. So, once we learn that, we will apply that to stress analysis of bars and beams, so that we can use this new understanding of viscoelastic behavior and apply it for structural applications. And finally, we will also look at how polymers fail, because again the way each material fails is different, and the reason why we learn about the failure is because we need to know what are the limits we can take this material to, such that we can get the best out of the design. So, once we cover all these topics, the aim is we should be in a position to design and analyze polymeric components. So, as I mentioned here, this process of designing and analysis is possible once we understand the unique behavior of polymers. So, again I am emphasizing or repeating, saying that polymers behave very differently from other materials. So, let us say I want to replace a steel shaft with a polymer shaft. I cannot simply copy the same design. It needs a complete redesign, because the properties are different and the way these materials behave is different, as well as the way these materials are manufactured is also different. So, overall we will understand both the structure of these materials as well as the mechanical behavior of these materials, and finally we will also look at the failure of these materials. The knowledge of all these three areas is required for us to really be in a position to design or analyze these polymeric components. So, in the next class we will be looking at the polymer structure.